Hello, everyone. I wanted to do a quick video to help you with a couple of extra examples of solving quadratic inequalities. So we did get to one example here in class, but I wanted to give you a couple more just to help with this. So again, our process for solving quadratic inequalities is you first want to get it into the form ax squared plus bx plus c on one side of your inequality and a 0 on the other side. That should feel pretty kind of normal. That's kind of what we want to do when we have quadratics. And I just put a square here. That's going to represent your inequality. It could be a greater than, less than, greater than or equal to, or less than or equal to. So put everything on one side, get a 0 on the other. And then I want you to solve the equality. So pretend that that inequality symbol isn't even there. Pretend it doesn't even exist. I want you to solve ax squared plus bx plus c equals 0. Mostly we're going to do this by factoring. This is going to be kind of the big one here. And then after you do the factoring, you can set each factor equal to 0 to solve. You can complete the square. You have the square root property available to you, or you can use the quadratic formula. But factoring is going to be kind of the biggest tool here to solve these things. And then once you get those solutions, I want you to put them on a number line. So you'll just plot those values on a number line wherever they are, smaller values on the left, larger values on the right. And then that's going to cut your number line up into pieces. And then choose one x value from each piece. Doesn't matter which x value you choose, just pick one from each piece. And then plug those test values into your inequality to see if they work. And then you'll write the solution in interval notation and make sure that you include all of the pieces that work. Okay, so let's do number 2 here. So I've got x squared is greater than or equal to negative 4x. Because I have an x squared and an x, I'm going to put everything on one side and try to factor this. So to do that, I'm going to add 4x to both sides, and I'll get x squared plus 4x is greater than or equal to 0. All right, everything on one side, a 0 on the other. And then now that I have this, I'm just going to pretend that that inequality symbol isn't even there. I'm going to pretend it's just an equal sign. And if I wanted to solve x squared plus 4x equals 0, I would try to factor this left-hand side. So first thing I'm going to do is look for a common factor, and an x will come out of both of these pieces. So I'm going to factor an x out. I'll get x times x plus 4 equals 0. Okay, so this is thing 1 times thing 2 equals 0. So one of those has to be 0. So either x equals 0 or x plus 4 equals 0. Okay, then I'm going to put these two, oh, sorry, and I need to solve for x. So x equals 0, or if I get x by itself here, x is negative 4. Now I've got two x values. I'm going to put those on a number line. Negative 4 is over here somewhere, and 0 is over here somewhere. Now think of having a knife or some scissors, make a cut here, and make a cut here. That would chop this thing up into 3 pieces. One piece is over here, less than negative 4. One piece is in the middle between negative 4 and 0, and one piece is up here greater than 0. We need to pick a test value in each piece. So I'm going to pick a value from there, a value from the middle, and a value over here on the right. You can pick any value you want to, and all of the values in the same piece will act the same. So my favorite number less than negative 4 is negative 6. My favorite number between negative 4 and 0 is negative 1. And today, my favorite number bigger than 0 is 2. Okay, so now we are going to take, these are my test values. We're going to take each one and plug it into our inequality. To be honest, you can use either one of these inequalities. I like the original one better, I think, but you can really use either one. I'm going to plug them into my original. So I'm going to get negative 6 squared is greater than or equal to negative 4 times negative 6. Now I just have to figure out whether this inequality is true or false. So negative 6 squared, that gives me a positive 36. Is that greater than or equal to negative 4 times negative 6 gives me a positive 24? 36 is greater than 24, so this piece works. All right, let's test the middle one. X equals negative 1. I'll plug it into that same inequality. I get negative 1 squared is greater than or equal to negative 4 times negative 1. Negative 1 squared is a positive 1. Is that greater than or equal to negative 4 times negative 1 is a positive 4? Is 1 greater than or equal to 4? No, it is not greater than or equal to 4. So this middle piece does not work. And then we just got to test this other piece. X equals 2. When I plug that one in, I get 2 squared is greater than or equal to negative 4 times 2. So 2 squared is 4. Is that greater than or equal to negative 4 times 2 is negative 8? 4 is greater than or equal to negative 8. That one works. Okay, so now I have all test values, and now I can write the solution. So we're going to include any pieces that work. So this piece, on these pieces on the outside worked. So it's everything less than negative 4 and anything greater than 0. So this piece over here on the left is going to be negative infinity to negative 4. To negative infinity is going to be a parenthesis here because we never include infinity. It's an idea, not really a number. And then the negative 4, to figure out whether or not we include this, I'm going to look at my inequality sign. Because there's an equal to down here, that means my kind of border pieces here are going to work, which means negative 4 will work, and I'm going to include it. And then I'm going to union that with everything greater than 0. So that's going to be 0 to infinity. Again, don't include infinity. It's an idea. And we will include 0 because of that equal sign in our inequality symbol. So this is our solution. And so this one tells us to write our solution as an interval. I also want to mention that sometimes when you're doing inequalities, Alex might have you plot your solutions on a number line. In that case, because we have the little equal to sign here, we would do closed circles at our endpoints here, like our solutions that chopped this up. And then you would just basically put a line over anything that worked to include it. So we could also represent our solutions on a number line that way. I just wanted to include that in case anybody was fuzzy on that. Okay, so let's try another one. How about number 3 here? I have negative x squared plus x plus 12 is less than 0. Okay, well, I have everything on one side and a 0 on the other. So the first thing I'm going to do is replace my inequality with an equals sign. So I'm going to first solve negative x squared plus x plus 12 equals 0. Okay, now to solve this, this negative 1 in front of the x squared is kind of weirding me out. And so I want to get rid of that. It's much harder to factor when you have a negative out there in front of the x squared. And since I have an equals 0 here, I can multiply or divide both sides by a number and still maintain that equality. So I'm going to multiply both sides here by a negative 1. So I'm going to multiply everything over here by negative 1, and I'm going to multiply everything on the right by -1. Then I'm going to distribute out that negative, and I'm going to get a positive x squared minus x minus 12 equals 0 times -1 is still 0. Okay, so my brain likes this a whole lot better. So a times c here is -12. So I'm looking for two numbers that multiply to -12, and I need them to add to my b value, which is -1. The two numbers that multiply to -12 and add to -1 will be -4 and +3. You can always split your middle term and and then chop it in half and take the greatest common factor out of each side. Um, but because our leading coefficient is 1 here, that's going to make our lives a little easier, and this is going to factor into x minus 4 times x plus 3. And we're going to have that equaling 0. So I'm going to set each factor equal to 0. So either x minus 4 equals 0 or x plus 3 equals 0, in which case x is going to be 4 or -3. Those are our two values that we're going to put on a number line. And I'll put that over here. And so -3 is going to be over here. And +4 will be over here. And so if I make a cut at each one of these, I'm going to have 3 pieces. Less than -3, between -3 and 4, and greater than 4. So I just have to pick a test value in each piece. You can pick any value you like, it won't matter. So how about my favorite number less than -3 is -4. My favorite number between -3 and 4 is 0. And my favorite number bigger than 4 is 6. Okay, so now to test each of these values, I'm going to plug them into my original inequality to see if they work in the inequality. So my first test value is -4. So I'm going to have negative, my x is -4 squared plus x is -4 plus 12 should be less than 0. To do this, -4 squared is a +16, but then this negative on the outside keeps that -16. Minus 4 plus 12 should be less than 0. -16 minus 4 is -20, plus 12 is -8. That should be less than 0. Is that true? Yes, -8 is less than 0, so this guy works. Sorry, this is going to get a little tight. And now I'm going to plug x equals 0 into my original. 0 squared is still 0, so that's just 0 plus 0 plus 12 is less than 0. This says 12 is less than 0. That's not true. So this middle part will not work. And then my test value for x equals 6, I'm going to plug that in. I have -6 squared plus 6 plus 12 is less than 0. 6 squared is going to be 36 times this negative will be -36 plus 6 plus 12 is less than 0. -36 plus 6 is -30 plus 12 is -18. That should be less than 0, and it is. That's definitely true, which means this outer part works. So now that I know everything, now that I have all my test values, I can write my solution here. So everything less than -3 and anything greater than 4 works. So my solution here is going to be -infinity to -3 union 4 to infinity. And these are parentheses because our inequality is a less than. There's no equal to there. So this is my solution to this problem. Okay, we'll do one last example here. I'll do number 5 down here. Okay, so I've got 3x times the quantity x minus 1 is greater than 10 minus 2x. I have a lot of stuff going on here. So the first thing I need to do is put everything on one side, get a 0 on the other, and I also have some algebra to do here. So first thing I'm going to do is distribute this out. So I'm going to have 3x squared minus 3x is greater than 10 minus 2x. And now I need to put everything on one side. I'm going to keep this positive, so I'm going to add the 2x to both sides and subtract the 10 from both sides. And so I'm going to have 3x squared. Negative 3x plus 2x is minus 1x. Minus 10 is greater than 0. Okay, now I just need to solve this inequality. To do that, I'm going to pretend that this greater than isn't there. I'm going to just solve the equation. So 3x squared minus x minus 10 equals 0. I'm going to solve that first. So I'm going to try factoring. We'll see if this factors. I'm going to do a times c here. 3 times negative 10 is negative 30. So I need two numbers that multiply to negative 30 and add to negative 1. Those two numbers are negative 6 and positive 5. So I can go ahead and split my middle term here. And again, I have to split my middle term here, whereas I didn't up at the top in number 3, because in number 3, my a value was 1. So you can just take your two numbers and put them in parentheses with x's. But because in number 5, my a value is not 1, I have to take the long way and split my middle term using these two numbers. And then I'll solve this by chopping this in half and taking my greatest common factor from each side. On the left, a 3x will come out, and I'll have x minus 2. On the right side, a 5 will come out, and I will have x minus 2. And I have a matching factor of x minus 2, so I'm going to factor that out of everything, and I'm going to get 3x from the first and plus 5 from the second equals 0. So now I can set each factor equal to 0. Sorry, this is getting a little messy. So that means either x minus 2 equals 0 or 3x plus 5 equals 0. So that means x equals positive 2 or 3x is negative 5, which means x is negative 5 over 3. So 2 and negative 5/3, I'm putting those values on a number line. Go from there. So negative 5/3 is going to be over here, and positive 2 is going to be over here somewhere. If we make a cut at each of these, I've got 3 pieces of my number line, and I just need to test each piece. So I'll pick one in each of these guys. Over here, I'm going to do x equals, just to make sure it's big enough, I'm going to do negative 5. In the middle, I'll do x equals, how about 0? I like that one. It's easy to work with. And then here on the right, I'll do x equals 3. Okay, so I can plug it into my original inequality, but this looks really complicated because there's so much going on here. I can also plug it into any of the forms of my inequality that I used to simplify everything out before I changed it to an equation to solve. I can use any of these to test, and I'm going to use this one down here because it's going to be the simplest for me. So I'm going to take the path of least resistance and plug it into this one. All right, so let's start on the left here. If x is -5 for my test value and I plug that in, I'm going to get 3 times -5 squared minus -5 minus 10. That should be greater than 0. So let's see. -5 squared is 25 times 3. That's 75. Plus 5 minus 10 should be greater than 0. 75 plus 5 is 80. Minus 10 is 70. That is certainly greater than 0, so this piece works. If I plug in 0, I get 3 times 0 squared is 0, minus 0, minus 10 is greater than 0. Negative 10 is not greater than 0. This middle part does not work. And then the last one, if x equals 3, I'm going to have 3 times 3 squared minus 3 minus 10. And my inequality says that should be greater than 0. Sorry, I'm running out of space. 3 squared is 9 times 3 is 27 minus 3 minus 10. 27 minus 3 is 24 minus 10 is 14. That is, in fact, greater than 0, so this outside part works as well. And so now that we have this, our test values done, our answers here are going to be anything from -infinity to -5/3. These will be open because our inequality is just greater than. There's no equal to sign. And I'm going to union that with my outside piece over here, which is 2 to infinity. That's our solution in interval notation. There we go. And if you were asked to plot this on a number line, because our inequality is just greater than, and there's no equal to, we will put open circles here and then just put lines over the sections that work. And so that's how you would plot this on a number line. Okay, I hope those help with a few more examples. This process of solving an equation and then chopping up our number line and using test values to solve inequalities, this is how we'll be solving inequalities for the rest of the term. So this is a process that we'll get really, really comfortable with. So start practicing it now and get good at it, and it will serve you very well for the rest of the term. Let me know if you have any questions. Have a great spring break, and I will see you in a couple of weeks.